Previously, we've looked at the R command, and the refresher on that is that we use the register modify R command to set our instruction pointer to the register to point to our location. So when we do -R, we're going to be pointing at the very first register that we have. We're using 16 bits, which is default. To AX, we have our BX, CX, and DX, and we know this is comprised of two 8-bit registers. So AX has like H high, which is HL, and H low, which is AL. So we have AH and AL, the upper 8 bits and the lower 8 bits. And then we have the same thing for B, C, and D. We went over all of these as well previously. And so looking at our lab report, we are now going to be looking at the trace command. And our trace command, we're going to be setting values in our memory. And so to do this, all we need to do is set these values. So we are going to be plugging these values in to what we have here. So if we do E200, then we are going to be 200 right here. And so inside of here, remember we're entering into 200. We're going to have our 20. We're going to have 01, 50, and the way we are spacing these out is just by pressing the spacebar. When we're done with this line, we're just going to press enter. Now we want to display these values. So we have 200, 201, 202, and 203 here. So that means we're going to do registers, we're going to dump 200 to 203. Pressing enter, we have 20, 01, 50, and 02. Now we're going to use our trace command. And this is where we have our tracing chart. So the first time we have our tracing chart, all of our A, D, B, and C are all zeros. Our NZ is 0 and our PL is 0. Also, our register right here is 0F68, and our location is going to be at 100 because we have our E100 here. That's where we are starting, and that's where our instruction pointer is, our IP. And so here, our DS200 is 20, and our DS202 is going to be this 50. Now, instead of using the 20 and the 01 and the 50 and the 02, we can change these values because I've already done this tracing chart here with these values, but we need to do it a second time. And so inside of here, what we want to do, and we'll just display our unassemble. So we're going to unassemble 100 to 118. And if we do that, we're going to get these. It's going to be the same exact thing. What we want to do is the E200 though. We want to enter into this. We're going to change our values to be from 20. We're going to have 10 space, and then we're going to have 15 space. We're going to have 5, and then we are going to do a space, and then this one is just going to be, we'll make it a 12. And then we're going to press enter here. And then so when we do our tracing chart, what we want to do is we want to start off with our R. And remember, the R is just going to set our register memory instruction pointer to the very beginning. So pressing R, we are going to get this. Here we can see that all of these values are 0. Our NV, NZ, and PL are also 0. And we're about to go over what these mean. So we'll take all of these, where CS is still 0F68, we can see that right here. And then our IP is still at 100 right here. And the 100 means it's just starting at 100. And whatever we have next, it's going to change this value possibly or possibly not. Our DS200, if we look at this line, we see that we are at E200, so we're entering into this line, so we're editing this part of our code. We have 20T, so 200 basically is 10. And then our 202, we have 201, and then 202 is just going to be 5. And what's our next instruction? Well, if we look at the bottom, our next instruction is a move DX, and then we have comma 120. And so that's going to be our next instruction. We have our flag names here. I wrote in the lab report. So if we have an auxiliary carry, we have NA if it's 0 in the reset state. So everything that we have, if it's this value, it's reset. And if it's at these values, it's set 1, 0. So we have auxiliary carry, we have overflow, parity, sign, 0, interrupt, and direction. So if we are to look at this, we see that for this, we have NV, meaning that we have an overflow of 0 here. There's no overflow. We also have a UP, which is our direction. We have EI, which is the part right here for the interrupt. We can see it is at a 1, so it's in the set state, not the reset state. And then we have more. So we have PL, NZ, NA, and PO and NC. So that's what we're going to have here. Now, these aren't the values that are extremely important. What is important is what we're looking at, the OF, ZF, and SF. So our OF, we see that we have an NV, our NZ is here, and then our PL is also here. So we're really going to just note when this changes. And if we wanted to, every once in a while, we can check our values in here to see if they changed by using the dump command. So we'll do D200 to 203, and that's going to check all of these values. So we have 10, 15, we have 05, and we have 12. I did 200, and I didn't do anything after that, so it printed more values because we didn't, oh, I said 205. This should just be 203. That's why it printed more values. But that's okay. We would just do 203 instead if we wanted the specific values. So to do the next trace, we're just going to do -t. The debug trace command allows us to trace through the program we've entered. Set the values in the memory locations first before running or tracing the program, which we've done above. We're going to stop tracing at the int, so int 20h instruction, determine the effect of our several instructions, and then try several of these values. So T, press enter, and we're going to have this. Our DX, we can just copy this because it's going to be very similar. Our DX is now going to be 120. So this changes to be 120. And this is because our 120 was moved into our DX. Our OF, which is NV, so NV is still the same. Our PL is still the same, and so is our NZ. CS is still the same. Now our IP is changed. We can see that it is 103. And the reason why it's 103 is because of the following. We have an instruction in here, move DX, where we have 3 bits. And since we have 3 bits, we're going to have to move up 3, which is causing the 103 here. Now we can look at the next values. So these are still the same, our 10, and we have a 5 here. We can do a T, but we should also update this move. So instead of this, we're going to be moving AX, we're going to be moving O200, so we can just write 200 here, into our A of X. So we kind of read from right to left. We take our 200 and we're moving it into our A of X. And so pressing T on this one, we get the following. We're just going to paste this in here. We have our A of X as 1510. And then our D of X is still 120. NV is still here. NZ is still here. PL is still here. So these are good. We have this, and since we have a 3-bit instruction, this should be a 106. Oh, that is our next instruction. This should be our 106. With this as a 106, we can look at our next instruction, which is going to be to move into our B of X, a 202. So we're going to take this and put it inside of there. Now on to the next one. So we've done all of this. We'll in fact, we'll just do a D 200 to 203 to make sure our values have not changed. We still have 10, 15, 05, and 12. So that looks good. Nothing has changed here. We'll do another T for our tracing. And so we can paste this in here. Actually, I'll copy this row since it's the most updated. We can see that inside of here, our B of X is going to change to 1205. Our C of X doesn't change and our D of X doesn't change. We still have our NV, NZ, PL. So this is the same. This is the same. So this is going to become a 110A. Now for this instruction, it's going to be a 010A. I'm just going to do a line just because of how Google uses their values when we have zeros in front. So our A is 10. So we know we basically have 10, 10. And this is hexadecimal for 109, I believe, because we have 3 bits inside of here that we're adding. Lastly, we got to update this. So instead of moving, we're going to be subtracting, and we're going to be subtracting from A of X our B of X. So we're going to take this B of X value, we're going to subtract it from our A of X and store the value inside of our A of X. Again, we're going to trace and paste in here. So I'll copy this and paste this in here. Our A of X has now updated. It's changed. It's a 30, and then we have a b. So 0, 3, and then a b. b of x is the same, c of x is the same, and then our d of x is the same as well. Our nv is still here, so is our pl and our nz. Now, for the IP it's the same, and so is our CS. We'll do a debug check, so D200 to 203, just to check to make sure our values have not changed. We still have 10, and we have 05. That's great. Now we look at the next instructions. So from the next instructions, instead of subtracting, we're going to be doing a jump greater than. So JGE, and then we have 114. And we know that in our code, this is going to jump. We went over that previously, and in the next video we are going to be looking at our actual formula for it. So we haven't done it yet, but we are going to be working on a flowchart for this. So going back to the lab though, we have 30B as we do here. We have all this upgraded, and so now we can do a T again and go on to the next thing. So this is going to stay relatively the same. We'll paste this in here, and we can see now that we are going to move into our 200 register the a of x. So a of x is going to go inside of here, and then all of these values are the same, nv, nz, and pl. And so we can copy this, paste this in here. I'm going to do a t just again, press enter, and then we get these values. We can see that we have 30B, 1205, 0, 120, NV, NZ, PL. Nothing else has changed. Oh, what has changed though, what should have been changing, is our IP. I never updated this, and we can't really scroll back. So what we can do is, hopefully we haven't gone too far, which we have not. We still see that we have a 010A here. That's good, because that was what this one is. And we know that's what this one is because we have our subtract here. So the difference here is going to be 4 bits, and then the difference here is going to be 2 bits. The difference here, we have a 10C here. We're going to have 114 here. So this one is just 114. And then this next one, we have a 117. So this one is going to be 3-bit difference. And that's because we are looking at this back one. This back one only has these 2 bits here and the third one here. And for this one, it's probably because it has these 3 bits plus this one here. So that's why the 4. And then we just have these 2, which would be this. And then the jump greater, then we have 114, which is 3. So that's how we would do that. And then we have our int 20. And that's this last part. So we stop at our int 20. That means we're going to replace this with our int 20. And that is the end for this tracing chart. It's very similar to what we've done with this one up here. This is just a longer example, and this is the second one we did. And again, that is done with our tracing chart. Next, we are going to look at the actual flow, because we never wrote that out. We are going to do a flow chart just to examine this code and how it really works.